This section is on linear measure and precision, how we measure things and how we determine how precise we are. We learned about lines and how they extend in both directions indefinitely, but if we just have part of a line that has a definitive length, stops at both ends, we call that a segment. Segment is a part of the line that consists of 2 points called endpoints and all the points between them. So know the difference between a line and a line segment. Know that a segment has 2 endpoints. Know that word, endpoint. So here's an example of what a line segment would look like. We have an endpoint A, endpoint C, and all these points in between make up the line segment. To name it, we use those 2 endpoints and we put a bar over it. Notice there's no arrows on the bar because it's not continuing in both directions. So anytime you see 2 capital letters like this, the bar over it, it's referring to a line segment. If there's no bar over it, like this, then it's referring to the length of the line segment. So you could say it was like 5 centimeters or 2 inches, something like that. No bar refers to the length of the segment. If things are congruent, this is a new word you need to know, it means that they have the same measure. So if we had 2 line segments that were both 5 centimeters, we would say they are congruent to each other. The symbol that we use is like an equal sign with a tilde on top of it. So know that symbol. Know what it means. It means they have equal measure. And we also indicate it by putting hash marks on line segments to indicate that they are congruent. So let's say I had like a triangle like so, and I wanted to indicate that this line or side was congruent to this side, I would put the 2 hash marks. If they're marked the same, it means that they are congruent to each other. Okay. So line segment AB is congruent to line segment CD because they both have 1 hash mark. And we would write it like so. Notice AB has a dash over it, no arrows. CD has a dash over it, no arrows, and we have our congruent symbol in between. Using symbols allows us to write things a lot more quickly and less wordy. Now, measuring a line segment. Because they have definitive endpoints, we can actually measure a line segment. We can't measure a line because it goes on forever in both directions. But a line segment doesn't. So we can measure it based on its 2 endpoints. The length of a segment is only as precise as the smallest unit on the measuring device that you're using. And I'll show you an example of that here in a minute. But if we have a measuring device using centimeters only, we wouldn't get as precise a reading as if we had a ruler with millimeters on it. So our precision is dependent on the measuring device that we use, how many markings it has on it. The precision of any measurement depends on the smallest unit available on that measuring tool. So again, millimeters would be more precise than centimeters. And the measurement would be precise to within half a unit or measure. So you're going to add or subtract half of the unit to determine your precision. And I'll do some examples here. So let's look at 2 different measuring devices. Here's a pencil. Here we're measuring with centimeters. Here our ruler has millimeter marks. So which one is going to be more precise? The top one, top measurement, or this one at the bottom? Hopefully you said the bottom one because it has smaller units of measure. We're not guessing as much. Here we would guess about 9.5, but if we look here, we see that it's actually going to be 9.6. we can get a more accurate measurement there. So again, here we would say 9.5 centimeters. So the precision of this measurement, we would take our unit of measure, which is the centimeter, and we would add and subtract 0.5 centimeter to our measurement to get our precision range. So if I do that, I would get a range of 9 to 10 centimeters. The precision is 9 to 10 centimeters. Why? Again, because we added 0.5 centimeter to get the 10, and we subtracted the 0.5 centimeter to get the 9. So we take our guess, our best guess, we add 0.5 unit to that, and then we subtract 0.5 unit from that. Okay, here's our second picture. If we measured with this ruler, we would get 96 millimeters because each one of these segments is 10 millimeters. So this is 95, and then again it goes to that 6 mark just past there. So what would our precision be? We would need to add and subtract 1/2 of our unit of measure. What is our smallest unit of measure? It's this millimeter. So if we add and subtract 0.5 millimeter, we get 95.5 to 96.5. Okay, so again, we added 0.5 millimeter to get, oh, I have that backwards. We added to get 96.5 and we subtracted to get 95.5. Betweenness. To be between, everybody knows what it means to be between, in the middle of. If we're between 2 points, we're on the same line segment. This point up here would not be in between. Between has to be on the same line segment. For any two real numbers, there is a real number between them. So if I called this 2 and I called this 5, then this could be 3. Okay, there's a real number between the two. So that number would be bigger than A, but smaller than C. Okay, just some kind of common sense concepts here. So we say that point N is between points A and C. If A, N, and C are collinear. What does that mean again? To be collinear means on the same line. So if that's true, if A, N, and C are on the same line, and N is between A and C, then we should be able to take the length of AN, remember, no bar above it means the length, so this length here, plus the length of N to C here. We should be able to add those together and get the whole length of line segment AC. That should be an equal sign right there. Okay, so let's say that AN is 4 and NC is 6. And what would be the length of AC? Well, according to our statement on the previous slide, we should be able to add the two values together to get the whole thing. We add the parts to get the whole. Okay, if AN is 3 and NC is 8, what is AC going to be? Again, we should be able to add the parts to get the whole. So you should get 11 there. Let's do one more. Okay, this time we don't know AN, but we know NC is 9, and we know the whole thing is 16. So what is the missing part? If we add the parts to get the whole, what are we going to do when we have the whole and need to find a part? Well, if we just follow our formula, we can add the two parts, and that equals the whole. Now, it's just an algebra problem, so you should be able to subtract 9 from both sides, cross that out, and our missing number is 7. So AN would equal 7. And that is it for betweenness. Now, there are things in geometry called constructions. To construct something means to build it or to make it. In geometry, way back when the Greeks started it, they didn't have all these fancy tools we have today. They used the very basics. So constructions are methods of creating geometric figures without the benefit of measuring tools. So we're not measuring anything, we're just drawing things. We usually use just a pencil, a straight edge. Though we may be using rulers, we're not going to use them to measure. We're only using them as a device to draw a straight line, and a compass. So we're going to be learning how to draw a lot of these figures that we're learning about by using those three things. Here is a place we can go to learn how to copy a line segment. Let's see if it's going to let me go. Nope. Okay. Okay, so here's a quick example of how we can construct a copy of a given line segment. So we already have this line segment drawn, PQ. Step 1, mark a point R that will be one end of the new line. Okay, so we're just going to draw a random point and call it R. Place the compass point on one end of the line. Adjust the compass width to the other end of the line. So we're going to stretch our compass all the way to the end of our original line. Now we got to be really careful that we don't move that compass length at all. And we're going to put the point of the compass onto point R. Now we're going to draw an arc with our pencil very carefully so that our compass doesn't move. Pick a point S on the arc to be the end point. Doesn't matter where. And then we're going to connect R and S. So RS should be the same length as PQ. Notice the congruency marks, the hash marks, to show that it is congruent. And that is how we copy a line segment using a construction, which uses just a straight edge, a pencil, and a compass.